Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have e to the power ax into cos bx, right? So what we have been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what is our y. So that's my y. Now it's quite evident that my y is of the format integral of u dv. So let me assume my u equals e to the power ax and my dv equals cos bx dx, right? Now something which is very unique about e to the power ax is how many ever times I differentiate or integrate e to the power ax, I will still have my e to the power ax term in the successive derivatives or successive integrals, right? And similarly, when you take the cos bx expression, right, the second successive derivative or the second successive integral, you are going to get back your cos bx, right? Keeping that in mind, I'm going to solve this problem using Bernoullis identity of integral by parts. And therefore, when we write our Bernoullis integral by parts, I'm going to write it only until the second successive integral and the second successive derivative, right? So let's write down what does our Bernoullis integral by parts states and then go ahead and solve this particular problem. So there we have my Bernoullis integral by parts. My integral of u dv equals uv minus u dashed v1 plus integral of v1 into u double dashed dx, right? So we have our u, we have our dv. So let's write down our u dashed and u double dashed first. My u dashed is nothing but e to the power ax into a, right? And my u double dashed is nothing but a square times e to the power ax, right? So this is what I meant earlier as well. So you look at u dashed, you still have e to the power ax. You look at u double dashed, you have e to the power ax again, right? Now let's go to our v1 and remember we also need our v, right? Because we have our dv. My dv is cos bx dx, therefore my v is sine bx by b. And now what is my v1? My v1 is nothing but integral of v dx, right? And what do we get? Now my v is nothing but 1 by b times sine bx, and therefore I can pull out the constant, which is 1 by b. And then what I have inside the integral is integral of sine bx dx, right? And do we know the answer for this? Yes, it's not too difficult. It is minus 1 by b times cos bx, right? So I already have a 1 by b outside the integral. Therefore, what I will get is minus 1 by b square times cos bx, right? So now we have our u dashed, u double dashed, we have our v, we have our v1, right? So let's plug it into our integral of u dv, what we have written down using Bernoulli's integral by parts. So my LHS is nothing but integral of e to the power ax cos bx dx. And then my first part of RHS, which is uv, right? So our u is e to the power ax and our v is sine bx by b, right? So my uv is e to the power ax into sine bx by b. Now let's come to the second part, which is u dashed into v1. My u dashed is ae to the power ax, and my v1, which we worked out, is minus 1 by b square times cos bx, right? So what is my u dashed v1? It is minus a by b square times e to the power ax into cos bx. We already have a minus here as a part of our identity, so that becomes a plus, and therefore my second part is ae to the power ax cos bx the whole divided by b square. Right, now let's move to the third part, which is a plus integral of, this is where I want you folks to observe this very closely. I have a v1 where I have a minus 1 by b square times cos bx, and then I have a u double dashed, which is a square times e to the power ax, right? So I have a minus 1 by b square times a square into e to the power ax cos bx, right? So I can pull out the constant, which is minus of a square by b square. So let's write that down. Then you have your integral of e to the power ax cos bx dx, right? So now you see your LHS has got integral of e to the power ax times cos bx dx, and let me highlight it using a specific color, say green. And I have the same integral in my RHS as well. So what happens if we do a little bit of rearrangement? I move the minus a square by b square times integral of e to the power ax cos bx dx to my left. So I have integral of e to the power ax times cos bx dx. And I also have a 1 plus a square by b square alongside that, right? I have e to the power ax sine bx by b plus a e to the power ax cos bx by b square. And for both these expressions, if I make my b square common in the denominator, what does my numerator become? My numerator becomes ae to the power ax times cos bx plus b e to the power ax sine bx, right? So let's write that down. Now I notice that e to the power ax is common, so I can pull out the e to the power ax in the numerator on my RHS, right? And coming back to my LHS, I can rewrite my LHS as b square plus a square the whole divided by b square times the given integral. So let's do that. So I'll be left with b square plus a square times integral of e to the power ax into cos bx dx equal to, remember folks, we've already cancelled the b square here on either side. So what we are left with on the right hand side is only e to the power ax times a cos bx plus b sine bx, right? So we more or less arrived at the final answer. I can move my b square plus a square to the other side, and what do I get? My final answer to this problem, and remember folks, we have our constant which we will add now, e to the power ax divided by a square plus b square times a cos bx plus b sine bx, right? So there we are. Let me highlight my final answer in pink, and I hope you found my content useful. Please do subscribe to my channel and support. Thank you.